Hi, everybody. Adam Savage. Yeah, there we go. That's better. What? I won't make you suffer through this whole piece to camera listening to that in the background. That is my new Sears Craftsman powered hacksaw. And as you can see, I've got this giant 6-inch round of cast iron that I'm slowly sawing through. I am doing that to an end because I've always been obsessed with, among countless other things, I have always been obsessed with vault doors, specifically the big round vault doors with the pins radiating out from them. There's going to be a fair bit of a preamble, so strap in. In my research, and I've been collecting pictures of vault doors for 20 years, and I've been obsessed with them for a lot longer. And this all begins, I'm in a bank with a friend of mine in the early 90s, and in the bank, you can see the vault. We're somewhere where you can see the vault, and my friend and I are staring at it, and because we've got a lot of time online, we just start counting the gears, the gear teeth and the gears, and we notice some symmetry. So a round vault door operates. It operates on a radial symmetry. So let us say that this is a 6-inch, which it will be, vault door. And each of these is a 12 millimeter pin. And there are 12 of them radiating out. And each of these, at the bottom of each of these pins that secure the vault door, is a tiny rack that engages with a spur gear. Here is a spur gear. And I plan to have 12 spur gears activating 12 pins, and they'll all be activated by a ring gear. That is what we were cutting in today's video. We were cutting this ring gear. Now, there are 3 relationships here in terms of gearing. There is, the easiest to note is that on every bank vault door that I have found a picture of that is round, and some are made by Diebold and some are made by other companies. And on every round vault door I've ever seen, the mathematics are self-similar. And that is that there are always 24 spur gears arrayed around the ring gear. Each of those spur gears in turn has 24 teeth. The main ring gear has 288 teeth because it's 12 between all 24, and that's 144 times 2, too gross. And all vault doors are the same math, 24 tooth spur gears with a ring gear that is on another base 12 system. I am, as I said at the beginning of this, this is 12. I am not going for the full scale 24 pin vault door. I'm going to do 12 pins for this one, but I'm going to mill it out of cast iron and steel. And that is one of my, this is a 24 tooth spur gear. And this is the smallest gearing I have yet worked with. This is modulus. This is a modulus of 0.5 millimeter. Modulus is the, this is not the video for learning about gear cutting. This is a video for watching someone else learn about gear cutting. I will know these things more as I proceed. Wait, where did I put the, right. So, and there are still companies making round vault doors, although they are making them quite differently. Instead of, I've seen both, but for the most part, the companies making big round vault doors today, and they're making them for like billionaire hideouts. They're really unabashed about it on the websites. They don't use a gear and rack system for pushing those pins out. They every one of these, On the modern ones that I can see, every one of these pins at the bottom is attached to a rod, which goes to this ring gear that when it turns, that rod straightens out and pushes the pin out. These pins don't have to move very far in order to do their business, to secure that door into the wall. And then this door is usually made out of plates of steel that are filled with rebar and concrete, so you can't drill through them. The walls of vaults are crazy. I've found articles about how difficult it is to take apart a building that had a vault in it because it's just rebar that is like this close times whole walls like packed with this stuff. There's a reason they put money in these things. So I am making the vault door of my dreams. I'm making it in dollhouse scale, 1/12 scale. And it's going to mechanically function even up to and including, I think I'm going to actually make a tiny little combination lock. Yes. And yeah, I do think I eventually want to send this door to the lockpicking lawyer and have him actually safe crack my safe. But that's way in the future. For right now, I have this lovely piece of 416 stainless steel because I'm going with a modulus of 0.5 millimeter. That's why I'm only getting 12 spur gears out of this thing. I would have to go to a much smaller modulus gear tooth to get the full 24 out of here, and I'm daunted by that. Maybe I shouldn't be, but I am. So I'm going with 12. And when you want, my ring gear will be a base 12 number of teeth, but it's going to be 120, not 288 or 244. Anyway, it's going to be 120 teeth. And at 120 teeth, that means it's 2.4 inches in diameter. And this is precisely within 1,000th of 2.4 inches in diameter. I really so I went online and I was like, I'd like this to be stainless. I'd like it to be hardy. And I go online and I discover that 416 is like the bread and buttery stainless, even softer than the 420. And I must say, I really liked machining it. You know, I'll have to do some work to get my finish better, but yeah, it's fun to machine. So what is about to follow is a very elaborate gear cutting setup. And that's what you'll witness. I'll cut. The last time you saw me cut gears, I think I was using these DP12 cutters. This is the new cutters. Look how tiny they are. They're so cute. These are the cutters that I'm using for the gear teeth today. And here is what the gear tooth looks like ensconced in its arbor. Yeah, so I'm going to, there's all sorts of, what will follow is about an hour of setting up, of just dialing in my mill so that my rotary table can carefully turn this piece of stainless in 120 small increments. And yeah, we're going to break out the dividing head. Woohoo! Hey, if you are a historian of vaults, I would like to hear from you in the comments. The next step I have in this is literally to call Diebold and see if they have a company historian and talk to them about why all these vaults are the same. Like, that's really cool to me, multiple makers choosing the same. And I have a theory about why they're all the same, but I'm going to tell you that theory once I have my rotary head, my semi-universal rotary head set up, because it'll make more sense once I have it in situ. That is square this way. It is square this way. It is square radially. I've added a couple of little shims in here. It is all turning true within a couple of thousandths, which is 0.5 of a millimeter. And I'm the correct depth, 44 thousandths in for this cut. I'm spinning in the correct direction, which is, yep. And this is locked and I have my gear set. So we're gonna do it. I'm gonna turn this around so you have a better view. So, 44 thousandths. And we're gonna lock there, right? Yes. All right. Oh, let's see here. That is meshing. I got my gear, I got my spur gear here, and I was just doing a little bit of a test and it's meshing. Hopefully it all works. All right, here we go. Whoops. All right, thought I was recording. Okay, I said I had a theory about why vault doors are all built in a base 12 system. And it has to do with these things. This is a dividing head. This is a similar machine to the rotary table down there in that it is a geared system meant to divide a circle into as fine of increments as you would like. You can cut prime number gears, 153 teeth if you want. I'm not positive that 153 is prime, but I'm just guessing off the top of my head. So you can cut prime number gears if you want, and you can just cut base 12 gears. And there is an advantage to cutting base 12 gears, which is that dividing heads often have a pin that goes through at these cardinal, at these specific points. So for this one specifically, this has a dividing plate that's dividing every, what is it? Every 15 degrees, I think. Every 15 degrees. And so I've just cut my 60th gear tooth. And I started off, let's see, I'll show you here. So remember I said that there is a pin that comes out and aligns? Here it is. Wait, here we go. There you are. See that pin coming out? Now that pin can only come out every 15 degrees and go into this plate. You see how this plate has these holes? One is every 15 degrees. So the fact that I'm at 180 and this goes beautifully in means that I have correctly done the math on this business to divide that into 120 of those. Yes. So this is the longest way of saying when you want gear teeth, there's some sponginess on rotary tables. You can get into the weeds with them by not being exact. And that alignment pin every 15 degrees, and it's different for different rotary tables, and there are rotary tables built to do this just like this. But the fact is on a base 12 system, most rotary tables will have stops at those key dimensions, which would make cutting a 24-tooth gear much simpler and straightforward than cutting like a 25-tooth gear, for instance. And efficiency is the key in manufacturing. So I'm not surprised after thinking about rotary tables and their ilk to find that these vault doors are all built off the same base 12 system. But still, I'd love to talk to a historian. All right, I'm halfway through cutting my gears and I'm really, really pleased. So we're just gonna keep on doing that and I'll keep on showing you some footage of it. Oh, yes. Yes!
It's happening!
This is really thrilling. This rolls all the way around. It engages. Oh, it's great. I'll show you a close-up here. I think I can undo all of these persuasions now. What? There goes the center. It's dead. Center's gone. About to pull this puppy out. What? There it goes. Oh. All right. I'm going to cut this ring out of this ring gear and turn it into an actual ring gear. Ring gear. So I'm so pleased. My hands are filthy. My face is probably also filthy. Got some things, but this. Oh, you know what? We don't want to look at it like this. Here, let's look at it like that. Yeah, that is me spinning my rotary table before I'd cleared the blade. I did that twice. again, I can cut out more of these guys if I need to. I have enough to make 3 of these ring gears. Just really. This just makes me so freaking happy. Oh, right. And then we've got, hold on, let's come back here. So, my rough depthing was that center to center, it came to just about 72 millimeters. And on the theory that metric gearing operates on whole integers, I just went with I drilled a 12 circle hole using my mill as a guide with a 72 millimeter diameter. And here's the moment of truth. Oh, what? Oh, dude. On my first, that's ridiculous that I got that on my first try. Because that looks like some really, wow. Oh, I'm so happy. Oh my goodness. This is great. Yeah, we'll get rid of those. You won't see those in the final product. Maybe I'll just put them upside down. There we go. Then they just disappear. I could even go, I could pull just a tiny bit out of that. Maybe I could. I'm so happy. I am so happy. This ring represents a real maturation for me of my process. Just to take a nice close look at it. A couple of small artifacts of me. I got a couple little, those two little, but that's not a big deal. I am very happy. Thank you guys for joining me for this one-day build. Oh, the whole thing's gonna be just so happy. See you next time.